Alright, on this episode of Captain Chaos Laboratory, we're going to work on a wild pumpkins ride. You can see. I did this is mine. I did the thing that I always tell people not to do. I didn't take it out of its box and display it. I've left it sitting in its box for years, 2 years, 3 years, something like that. And when I took it out of the box a week or so ago, not having any movement. But as you saw, the lights and the sound do work fine. I just lost my movement. So I'm assuming it's going to be either a bad drive belt or a bad motor sitting in storage. So first thing we're going to do is remove the little magnetic pumpkin characters and set them out of the way. And this thing is so fragile, being the plastic that it is. On the very bottom we have, well, technically there'd be 9 screws, 8 screws, sorry, I math well. But it looks like there's a couple that fell out, which doesn't surprise me. So I think I bought it secondhand. I don't remember. It's been a while. So, and it's possible I bought it to fix. I don't remember. I'm working on my display, getting it set up, even though it's after Thanksgiving. I'm sorry, after Halloween, just before Thanksgiving. And mine's a year-round display, but I've not been able to complete it due to I work too much. And when I'm not working, I'm fixing Lemax and other electronics. So, since I've been working on my display, so I can get a nice full video for all the viewers out there of what I have and how I have it displayed in the custom room I've done for the display, I'm setting up all my stuff. And I found I have a couple of pieces that have malfunctioned. Alright, I'm just resting it carefully on its back, as you can see, and I'm taking out the screws that are here. And we've got a notch here, notch, notch. So there's 1, 2, 3, 4, 5, 6 notches, which all have the wires coming out for the lights. And there's a tab that covers the power supply at the very bottom. Right there. So, I'm going to assume, and I'm right, the bottom just slides right off. Hey, look at that. Well, that could be a problem. The motor's severed. Interesting. Well, since it's apart, let's see what makes this thing work. And I'm going to test the motor. Maybe the motor's bad. You know what? Let's test the motor now. Why wait? Turn on my power supply. And I'm going to, I don't know why I'm even bothering that part. Set my power supply at 4.5 volts. Actually, let me set it a little lower. I'm going to set it at 3 volts. The reason I'm doing that is I'm not sure of the actual power that goes to the motor. Standard hopping motors from Lemax run between 3 and 12 volts, so it should be fine. This one has a motor code. You can look it up, but it does not give me the voltage. But I'm going to assume red is hot and ground is not. So red. It is working. So that's at 3 volts. Let's try 4.5 volts. It sounds like it's straining. That sounds better. There's 1. There's 2. 3. 4. Where are you hiding? 5. Now it's stuck, and it is hammering on power. The amperage is spiking to almost 1 amp. Most of the controllers are only rated up to 1 amp, or the power supplies. So we definitely got a problem. That's probably why this has been cut. So I probably did buy it secondhand, because the motor was probably overpowering the power supply and burning out the power supply. That's not always a good thing. Actually, it's never a good thing. So let's take this apart. First thing I'm going to do, like I recommend a lot now, is I'm going to take a picture of these wires on the circuit board and the power port. The power port has a light gray and a white, or 2 white wires, 2 different shades, connected to, looks like the negative, and then a pink connected to the positive, right there. And does this little guy pop out? Or is it glued in? No, it's glued in. But you know what? I own glue. See if we can pop this thing out just to make it easier to work on the base without worrying about breaking the wires. Wow, I use good glue. Alright, scratch that. Well, I took the picture, so what I'm going to do is I'm going to desolder these 3 wires, the pink and the 2 whites, or white and gray, or whatever you want to call them. And that way I can work on this, completely isolated from this, so I can move this out of the way. Be easier to see how this magnetic pulley system works. So while we're waiting, let's remove the cover, which is multiple layers. Kind of nasty underneath. Probably have to clean that. Get that out of the way. You can see how it works. We got magnetic pads, 1, 2, 3, 4, 5, and oval or oblong cutouts on big gears. Don't break these. These will be really hard, if impossible, to locate. These guys, probably not as bad. These dudes, good luck. When you start using oddball stuff on Chinese equipment, don't forget they're made in China, it gets hard to find replacement parts. Alright, so desoldered the 3 wires. Now I'm going to set this out of the way, like so we can just address the drive mechanism. The drive mechanism does not come in from the bottom. There's no holes for the screws. So it's going to be these 3 screws here, this screw here, and possibly one here. It looks like there was a screw at one point that's probably missing. Now this screw is going to be a pain to get to, so I have to disassemble the top of the transmission or gear cluster. I have a funny feeling it's got a broken gear, and that's why it ran and then bound. We're going to find out. So, can't get this gear, so I'm going to go ahead and remove the top here, which has 4 screws. which these 4 screws and the 4 screws below it are the same. So technically, if you mix them up, it's not a big deal. I'm still going to separate them. So, carefully pull the top off. There's my gear cluster. Normally this little guy right here would be the broken gear. And you know what? Let's give it power again and see if we can see what's binding. The reason the gear shot out is because there's no tension on the top post for the gear shaft. So I'm going to put my finger on it, try and hold it. And you can see it's working. You can see how it works, where it transfers the little eye-shaped items between the different gears on the different paddles. Technically, you could change the timing if you don't like how close some of them are getting, like these two right here to me are a little close. If you unscrewed this, you could move this over to this paddle. As long as it doesn't interfere in its Mickey Mouse head shape, you're fine. But now she's working. But we're still going to take it apart. So, take out the last screw. So 1 gear, 2 gear. Wow. I don't know if you can see all that black right in here. That's the belt. So I'm wondering if the belt's slipping. But we're going to check this little 10 tooth and see if that's not the culprit of the intermittent failure. So I'm going to put on some magnifying glasses and take a look. This motor, in case anybody wants to try and find it, is an SRF, like Sierra, Red, Frank, 500 TB, like tuberculosis, or Tom Brady, if you're a football person. It's a 12 volt. It's an actual pretty large motor, but it's probably because of the amount of force it has on it. This is a really fat belt. This is actually an O-ring. So the belt must have snapped. It was replaced with an O-ring. Interesting. So, I'm going to give her some juice again. And I'm going to put some stress on this and see if I can find out if the motor is failing intermittently or if it's one of the gears still. So I'm going to put stress on it as I'm going to try and slow it down with my finger. Well, she's going up to almost a ½ amp, but she's still spinning and she's not slipping the belt. Whew, it's tough on the finger. So, you can hear it. Let's check the rest of the gears. Looking for chip teeth or fractures in the plastic. Like I said, normally that little one is the one that breaks. I see nothing. So let's check these big ones, because there's a piece of debris right here. A hard piece of plastic. I don't know. It's gray. I wonder if it's a piece of that mat got stuck inside. But let's find out. So, if you want to change the timing of these, you could technically just remove these 3 screws, or this one too, to remove the center disc. If you remove the center disc, you can then move these. You can also do it by removing all these other screws, which there's what, 1, 2, 3, 4, 5, 6, 7, 8, 9, and pull the entire outer plate off, which is what I'm going to do. The reason being is if I want to turn this back on, the outer plate, all it does is help align these, while these inner screws help keep the big gears in order. I'm going to check all the teeth and see if there's any binding, chipped teeth, any wear I can see, because come on. There we go. Gotcha. And there is your drive mechanism. It's actually pretty ingenious. Like I said, because these little guys technically can be removed and repositioned. So it's right here. That's where it was originally. So you can technically change the timing of everything just by taking off one of these caps or taking off the big outer section. You might be able to see the debris from the old belt now. There's a lot less stuff in the way. Now we can take this gear out, check it. It's a very interesting gear. It's got a square shaft and really large teeth, and then obnoxiously large teeth, of course, to drive those. It's got a plastic bushing, and it's not cracked, so that's not causing any binding. What I'm doing with my fingers is I'm moving it to see if it would, as if it was together. See, that's where you can have a problem. See, now they're hitting each other, so there's a timing issue. Slide that one over. Let's put that one here and see what happens. One will go there. One will go here. These will just stay where they're at. Alright, so now we got some binding. Binding and timing again. This might be my problem actually, because this gear has a lot of play in it. Yeah, great. So this big gear here is my issue. I don't know if you can see, if I wiggle this gear, it's nice and tight. I put this back on. See all that movement? Also, if you look at the hole where the up shaft or the pinned shaft comes through, you can see it's slightly bigger. And we take the gear out. Inside here, it is shredded plastic. It is, yeah, that is powdered plastic and grease, because of course it's lubricated, it's oil. So remember that thing I said about that's the gears you don't want to have fail? Apparently I have one that failed. So, just as comparison, also let's make sure the timing on this is right first before I... Yeah, alright, so my figures won't hit each other, and that's all I care about. So if you change your timing or you change your spacings, you're going to have to adjust your little magnetic boats, or whatever you want to call them. So these two gears the same. Yep. What I'm doing is, I believe this is just wallowed out, and that the stud isn't, which it's not. It's a nice tight fit, no slack. Because they're the same gear, I am going to swap them. There's a reason, is I'd rather have the first gear that transfers all the torque have an issue than the middle gear that distributes the torque have an issue. There we go. So what I'm going to have to do is make a bushing. What the bushing is going to do is take up this slack, this lateral movement, and try and recenter that gear so it doesn't do this and bind against, for instance, this gear now. I don't know if you can see on the camera very well, but as I'm turning this, you can see this gear is walking back and forth. That's not good. And if I keep it under torque, it tries to stay to one side. But what's happening is it's getting wedged because it's going off center for the teeth and they're binding. So, like that's a plastic bushing. There's an actual insert right in here for that shaft, so that the shaft doesn't wear out any standoffs. The plastic is probably a nylon bushing. Nylon has a very high wear rate, or wear life. This one has two inserts. I'll try and close up. One there, one there. Those are, so I'm sure they're nylon inserts. So that way the wear on the actual, yeah, there's none up here, but that's probably due to the fact that the torque is going to be on the bottom. Also gravity. So yeah, we're going to have to make a bushing. Most bushings on most things are like bronze. But I'll have to go through my stuff and try and find something that I can use to probably bore this hole out slightly bigger that has the same inside diameter for this, and then slide it over and take up all that slack. For instance, this, they make these for electronics, which is a electrical bushing. I'd have to find one that's a similar size and fix this. So now I know why probably the previous owner cut it. It's because it was binding and putting an extra load on this motor. This motor is pegging to about a half an amp, and that's about 50% of the power supply's rating. Then when it locks up completely and it surges, it's surging up to 1 amp. And most of the Lemax power supplies, especially the one I'm using on this, is 1 amp rated. And then the newer ones are actually only 750 milliamps. So those you could potentially burn out. The teeth on these gears look good. The motor sounds good. It can handle the pressure of me trying to stop it. I want to say whoever worked on this before put the bushing on upside, or excuse me, the pulley on upside down, because this nose, oh, never mind. This nose is generally down to keep it spaced off the motor, so it doesn't compress into the motor and bind. But because it's mounted this way, it's keeping it up, and there's a little indentation right here for the motor, the nose of the pulley. So it's only backwards because of the piece Now let's take a look at this part. The part with all the electronics in it. Untangle that. You can see where they stuff it all. You got your circuit board. I'm sure the blob chip is on the back. You always have a blob chip. You got your 8 ohm, half watt, full range piezo type speaker. The power supply notch right here, which these are the wires, of course. And you have all your wires for your lights. You have the varnish or lacquer covered wires that go up to your light poles. Then you have your actual vinyl insulated wires which go to the pumpkins all the way around. Yep, only the pumpkins. Even the pumpkins on the trees. So. And there's the blob chip right here, sitting off to the side. So we're going to stop right here so I can try and find something to make a bushing out of. So we can fix this, get it back on display. Functioning on display. Instead of just sitting dark in the corner where just as a space saver. So. Alright. Shall return with hopefully a fix. And once of course I find it, I'll show you or explain to you how I got it done. So we will return. Alright, we're back with some tools. So we need to make a bushing, as I was saying. And what I have found is, first I mic'd the holes. So this inside hole that's all wobbled out is 318. And this standoff that it's screwed into right there is 0.279. So I went through my buckets of stuff and I have some of these hard nylon bushings which I dropped. It is bigger than this hole, which is good. I'm going to drill that hole out so it's the same size. And it's smaller than that hole, which is fine. I'm going to drill this out to the right size. But it's also thicker. It's about twice as thick as the gear, which is fine. I'll shave it down once I do the proof of concept that it actually works. So get a little more light onto the situation. So I used a standard caliber mic, whatever you want to call it, to measure the outside and the inside. So I knew I could get something that had a similar hole and a similar diameters. And this is the closest I could find. It's a solid piece of white nylon. This was a spacer. I believe it was from an older model television. Now they're usually black, the hard plastic spacers for mounting your TV to a wall. This one just happens to be nylon. Of course, I would not recommend holding this. This is why I'm keeping it thick, so I can put it on a pair of pliers to drill it out. Because if it was thin, the force of squeezing the pliers could crack it. So I'm going to drill it out first. Or try to. A little bit. I cracked. So my proof of concept didn't work. It split. I might have to go with something a little softer. I have some rubber ones that'll fit, but I don't want to use rubber because rubber, as it spins, can get hot even with lubricate and stick. So I'm going to have to go through my drawer of bushings again, see what I have. I have some of the black plastic ones that they use on modern TVs. Maybe I'll try that. I was trying to stick with the nylon since this is a nylon type gear, nylon plastic. But it may not work. It might be too brittle. which scares me a little bit since this hole might have to be close to this size, and you can see that's a pretty big hole. We'll be back. All right, take two. I got the black bushing, which is much taller. It just doesn't fit. This is, again, for TV standoff. It's the modern ones. Problem I have is the drill bit is the same size as that. Excuse me. It's 0.0. It's 9/10,000ths of an inch smaller. So of course it will be tight. I don't want to go too big. I don't want too much slop. That's still too tight. Sorry for the loud drill noises. Almost. All right. So, step one. We're going to make the bushing fit on the inside so it fits over the standoff. Now we need to make the outside. And let me make sure this is still a 1/2 inch. This is just a hair bigger than a 1/2 inch. It's 0.502. And this drill bit is 0.499. So, if the drill bit goes through and does not break this gear, I should be able to do it. I'm probably going to have to get some other drill bits and slowly step up the size so it doesn't break. So if this gear breaks, I'm going to have a problem. So I don't want to break like this last spacer did. So I'm going to see what I can do about making that this size without breaking this, because I think this is going to be too aggressive and it's going to crack this, and it's probably going to crack it right on the seam, which there's a seam right here. I don't know if you can hear the clicking when they cast it. So might have to just take a smaller drill bit and walk it out. I might try a step bit. Those are the bits that are segmented where it's small, medium, large. It gets bigger as it goes down. They're usually not as aggressive. But I need to round this out to the outside diameter of this, which is going to be approximately a 1/2 inch. Step bits are nice. They do come in metric and standard. Since this is a 1/2 inch, a 1/2 inch hole, should be able to slide these two together. Also, because of this extreme height, I'm going to have to cut it to where it's approximately that thick. So that'll be a hacksaw with the straightest cut I can possibly do. But what I guess is kind of nice is because how tall this is, if I screw up one, I have enough space to make several. Unfortunately, the camera doesn't go where my hacksaw and this device is outside. So I'm going to have to go outside real fast, slice this down, and drill that out, and make them fit. Hopefully it works and I don't come back with a broken gear. So, be back in just a moment. Alright, back again. And it worked. So, this is the step bit I used. This top section is 1/2 inch, which is the outside diameter of the black. There. What I did was I got a piece of scrap wood. It was a old plank. It was a 2-inch thick plank. I drilled a hole through it with this, which got this nice and hot. Then I drilled out the inside of this. Now this being extremely hot, because I burned myself on it, allowed the plastic to melt. As you can kind of see right there on the edge, you see this ridge. That ridge isn't really from the drill bit going through, that's the plastic melting. While this was still gooey hot from this, I pushed the black spacer into it. So that way when this cooled, it's now one piece, no glues required. It's like sonic welding. It's where you heat up two materials, shove them together. When they cool, they're kind of permanent. But on plastics, you usually do it with vibration, not a drill bit. Anyhow, so the bushing's in, which now slides on. And hopefully we'll keep this centered. Of course, I probably just screwed up my timing by turning it without paying any attention. But we're going to find out here. So, next, I'm going to lubricate this because it's dry from being drilled. So I got some silicone spray lube. It slides better. I'm not going to screw this on. I'm going to use this for the guide purposes. I guess I need to also put this in, which is the transfer gear. And I'm so excited to try it, I'm getting ahead of myself. So I need that flat screw that holds this down. There it is. Screwdriver's right there. There we go. Now that and this. You know what, let's, there we go. These all have recessed for these. Instead of fighting with all the screws, because I'm just going to hold it down, I'm just going to knock all the screws out as you saw. And I have to reassemble the gearbox. Right. Oh, it's right there. We definitely need to pay attention to what I'm doing. That's that one. that, and perfect. If this is boring to you, you can skip forward. I need to put a couple of screws in here so the torque doesn't cause the cap to pop off and then cause the gears to go out of alignment, which then could potentially crack the gears. So just put a couple of screws in. Hopefully that's enough to hold it. Yeah. Let's get the power. Move that off the bench. Forgot that the top of the one gear here actually goes inside this box. So I'll loosen these up so I can lift the corner. So and I'm going to put a couple of screws in here so I don't have to hold the motor assembly down while doing this. Because I'm going to have to hold this top plate down so as the pieces maneuver around, they don't get wedged and pop up. Said it before, magnetic screwdrivers can be a lifesaver. Unfortunately, these are not magnetic, this set. Nope, still wedging. Let's make sure it's not any of these. Oh, that one's tight. Alright, still got a problem. Ah, that's a problem. This gear is proud. Which means it sticks up. So my bushing is a hair too tall. So there's a little lip here. Little sandpaper. Let's see if I can wear off some of that. Ugh. Should have dried off all the lubricant first. Get rid of some of this height. Looking to see if I have any other grits. I do. There we go. That's 150. And this is 150 as well. If you ever do custom stuff or get custom stuff, you know it's always trial and error. Doesn't appear to be proud anymore or higher than the other gear, but I'm going to screw this back in, and if it works I'll re-lubricate it since I just sanded off the lubrication. It's all trial and error. If you have suggestions on a different way of trying and erroring, let me know. I'm always open to suggestions. That's how we all learn. If you had a 3D printer and a program and you were good at it, you could technically probably make this gear on your 3D printer out of a somewhat hard plastic. I don't got a 3D printer. So I have to do it the mechanical way. Well, she seems to be working. That's the actual correct voltage now. It was a couple of tenths of a volt short. It's a little bit quicker. So, before we superheat everything with friction, lubricate. And because I could hear the motor straining, so I wanted to get this lubricated. And what I'm going to do is put some screws in to help hold it now. If you're missing a screw or two, I'd probably suggest trying to find a replacement, especially on this piece. I could feel it while holding it because this guides these, and especially right here where it transitions into its double figure 8. You don't want the screws missing. If you happen to lose a screw, I think the screw I'd not put in would probably be this one. This one would have the least amount of torque on it from the rotating masses. Try not to lose a screw. A lot of cheap electronics, cheap toys use the exact same screws. If the threads bite and the head fits recessed inside these holes, then use it. I would not suggest gluing it together in case you ever have to take it apart. Those guys might hit each other. It's getting harder to turn with the added weight. doing is I'm seeing if I tighten this down too tight and it's putting pressure on these lips. So I'm just backing the screws off of here to see if that helps relieve any stress. Because this plate is pushing on the edge of these eye-shaped guides. And if you squeeze it too tight, it's too much friction. I'm also checking the belt to see if it's slipping. You can see the belt in here. You can't, but if you ever take it apart, you can. So I'm checking to see if the belt's slipping on the pulley. I'm feeling the motor to see if it's getting hot. I think all the gears are lubricated now. So it looks like this is the biggest part. Right now it's pulling 200 milliamps or 0.2 amps or a fifth of an amp, depending on how you want to look at it. It's wavering back and forth between about 0.19 and 2.21, but it's averaging at 0.2 milliamps, or excuse me, 0.2 amps, 200 milliamps. I'm not sure what this thing's supposed to draw as far as power consumption. Most of these units are usually close to a half an amp. They usually draw close to 400 to 500 milliamps or a half an amp at the most. So this might be within tolerance. I don't have the original manual that tells me. I could probably look it up on their website. Sometimes Lemax, on their Lemax collection website, tells you the milliamp reading. That way you don't overload a multiple head plug. If you have three things that draw 500 milliamps as an example, and the head's only rated for 1000, you're going to overheat that plug, potentially burn it out. Or the computers are going to fight each other, and the one that's the weakest, you might fry the circuit board. But I think we got it. It hasn't stopped. So I'm going to put the other screws in while it's still running around. That way I know if I over tighten them and pinch it. Not liking that screw. There we go. A little bit better tip. Also, it's a number 2 versus a number 1. You can hear when I don't know if you could hear it, but I could. When I tighten this one down super tight, the motor changed pitch because it's pinching the edges of these two. So they're snug. There's no movement. It's just flexing because of the plastic in the guide top. I think we're good there. I am going to have to take these two out to put the screws back in the bottom. So I'm going to turn this off. Pop out these two screws real fast. So. And put one more. This one was missing one. Now put this cap back on, line up the studs for all the different gears. Yeah, there we go. So if this continues to work, I'll clean off the face, stick on the plastic cover that has the tracks on it, little white dashes, and then solder the two wires back on with some heat shrink to protect, and reassemble. Oh, I guess I'm going to have to solder new wires on since that solder joint just broke. So there's either oil or grease on here. Don't know why. It could have been from storage. It doesn't mean it was sitting upright the whole time. That's not good. Why'd she stop? Alright, that might explain why this is greased. And this grease picked up all the stuff from my workbench. Yeah. So I think that's part of my problem. So I am going to spray a little lube on this. Work it around. It's getting stuck here. problem is it's getting caught right here each time. Thought maybe it had to do with this thing slipping, meaning sliding back and forth. Because those magnets do touch. This magnet doesn't. These two of the three magnets on the double figure 8 are missing their plastic slip guides, and I don't know if that's the problem. What I'm talking about is if you look at the magnets, these two are white, that one's white, that one has some of the white there, and that one's all silver. Those little pieces of plastic that are glued on the top actually allow it to slide on that plastic here. So that might be part of my problem. Also, I have to hold this mat, because once the magnets are on, the mat tries to move with the figures. So, let's try it again. I think this is probably how that gear got wallowed out, is it keeps wedging, and every time it does, the torque. Now, it's this one with no chunk of white in it, so I'm going to try it again and see if it's the same one that keeps getting caught. Now, to rule out it's just this one, I'm going to stick this on the one with the white slip. Process of elimination, because I can't see it, and I don't want to just use the clear mat, it's two pieces. I want to use the full thing it's supposed to be. So, they're all getting wedged. For now, I'm just trying to see what's causing it. Let's put the stress back on it. So, something about having the mat on top is causing the issue. The mat originally was glued down in the four corners. I'm going to try just the mat. It's going to be tough on the mat with those things sliding across it without the clear plastic. Now, this is going to take some playing around with. Alright. Well, we got the gear problem solved where it's not binding when it's not under a load with the mat. Now I gotta sit and figure out what's going on with these getting caught in this area, because they appear only to be getting caught right here and not right here. And the plastic is chipped or damaged right here. I'm wondering if that is my issue, is this piece right there, that if the damage is either a factory defect or something that happened during ownership, because it was used. I did check, I did buy this used. So I'm going to play with it a little longer and see if I can find the problem and rectify it. That way you're not bored just watching me do this for the next God knows how long. So, shall return once I figure out what's going on. Alright, after some playing with it, I think I've figured out the problem. So, let it run for a second to show you that it apparently is working. Had it working for a couple of minutes, but I'm going to show you on camera. Make sure that Murphy doesn't kick over and accidentally, make it stop working. I don't have these on because those weren't the problems, but they work fine too. See? Now this is one I would not put on a 3-head adapter unless you just have like a lighted sign with it, because under full load it is pulling close to a 1/2 amp, including the lights for the top piece. Like I said, most adapters are only rated for 1 amp at the most, so if you have this and another piece, you could smoke your adapter. So if you had a 3-head adapter, I'd put this on there and maybe like a set of lights that plug in with the 4.5 volt power supply, or even one of the billboard signs, but not another house, not another large piece because of the strain. This is a high torque motor, and when it gets put under torque, you can hear it, and it causes the amp gauge, which is off camera, to rise. All right, what the problem is these little eyes. I'll show you. Take this piece out instead of taking the entire ring. I'll grab this one. If you look at the shape, you'll see that it has a leading edge that sticks off and a leading edge underneath that is recessed. When I took this apart, I could have sworn they were put in this way, where the leading edge was this part. The part that's protruding out was going around first, and that's why it was wedging. Since I've reversed it and made the pointy part overlapping the tooth, trailing, or being behind, I have not had any binding issues. And I had it running for, 2, maybe 3 minutes prior to turning the camera back on just to test it. Because what I was doing is I was just watching it. Watching what was causing it to get stuck. I'm trying to line up the standoff so I can pop this back on. It's a little slick because I lubricated everything. That's why it's kind of shiny or glossy in the camera lens. At least it is on my side. Just going to make sure these are all snug. Because now that it's trailing, I don't want these to be loose. Real loose, there we go. I was just testing it with the clear plastic. The clear plastic was working fine as far as allowing me to see why or where it was binding. After I did the clear plastic, I went ahead and stuck the gray sheet underneath it. There we go, clearing off some of the debris. Once I was done and I got it to where it wasn't binding, I took some of the silicone lube and I sprayed the tops, which is why some of these still have shine to them. And that way it helps slides on this. So that way, less friction. You could use a thin grease, and I mean thin. Use anything thick, like the consistency of Vaseline thick. It's going to cause it to slow down dramatically and possibly overheat the motor. And we don't want to do that, because if it overheats the motor, the circuit board is going to fail. So anyway, I'm going to go ahead and reassemble this, and then we're going to test it out. Be back in a few moments. All right, it's all back together. It's running on its own AC power cord. All the pumpkins are moving around, all the lights work. Apparently I lost a pumpkin right there. Not sure if I had it when I took it apart or not. Have to go back and check. Maybe it fell off in the box. But it's all back together. So I'm going to turn off the light so you can see it. And off. There it is. So, it's kind of a pain. Didn't expect to have to shim a gear and figure out that potentially those pieces were in backwards. Again, I don't remember if I turned them or not. I doubt it, because the other ones are facing the same direction as those. So these three were facing the same as those two. Now that I reverse these three, she's not binding anymore. So if you're having an issue with the pumpkins binding and it's not a bad belt that broke or something, maybe switching those around will help you. If it's not moving, you could have a bad belt, wallowed out gear, cracked gear. But as far as this one goes, it was cut because it was probably binding and sounding horrible. And it had a wallowed out gear, which kind of saw how I did it. I found a bushing, drilled it out with a step bit that I could find it would match the inside's diameter for the stud and the outside diameter for the gear. And then I pressed it together using friction, where when the plastic was really hot from the drill, I pressed the pieces together so no glue was required. And how I heated the drill bit was I drilled through a plank, a 2-inch thick plank of wood. I drilled one hole through on one way, then made it the same size going the other direction, which got that step bit extremely hot. So it caused it to cut through the plastic easier because of the heat. Also reduces the chance of it cracking when you do that, because a cold bit, you can crack the gear easier than a hot bit because it'll help melt the plastic, warm it up. Then pressed it together with my fingers, held it, sawed it with a hacksaw. I thought I had it smooth enough. When I sanded it, I didn't. You saw I used sandpaper, 150 grit, until it sat flush and didn't walk up on top of itself, and put it back together. That spray can of lube is a silicone lube. It's to replace graphite for door locks, because sometimes graphite isn't the best choice. But it is a silicone spray. Any silicone spray should do you good. Or a silicone lubricant grease, like a very mild, very slick grease, not a thick grease. If it's the consistency of Vaseline, you're going to have binding issues. This thing right now is, like I said, pulling about a 1/2 amp. And on a power supply, you want to make sure you don't exceed the rating in milliamps. So if you're pulling a 1/2 amp and you have a 1000 milliamp rated 3-head power supply, be very wary of overloading it. There are a few pieces that Lemax makes that run a high amount of power, especially the ones that move a lot. Like the tilt and hurl draws almost 400 to 450 milliamps, which is close to a 1/2 amp again. There's also a mortuary piece that has a spinning wheel around the outside of the house. That guy pulls with everything running, because it's technically 2 pieces put together. It's pulling close to 800 milliamps, which is 0.8 of an amp. So be very wary on heavy duty pieces not to overload your power supplies. So hopefully this helps with the dismantling, what you can expect. Doesn't have a circuit board issue, so I didn't have to really pull it out. I didn't want to try and pull it out either, because those thin lacquer wires that go to these lights here on the ends, they're very, very fragile. I know I broke them on the tilt and hurl, if you watch that video. The wires that go to these pumpkins up here, and over here are a much thicker wire that you're less likely to break. Still possible, but not as prone to snapping. You can tell I definitely soldered the wires back together. I put on a small extension piece with some heat shrink, connected them to the old one, soldered it. If you watch previous videos, you've probably seen me do that before. I'm just trying to reduce the length of this video because I know this video is pushing over an hour, like an hour and 20 minutes. So I didn't expect to encounter so many different things just to fix basically one problem, which was a bad gear. It's not really broken. So anyway, hopefully this helps if you have a Wild Pumpkins ride with it not spinning, and if it's not a broken gear in the small gear pack that's back here, or a broken belt, then you might have a wallowed out large gear. And hopefully what I have done has helped you repair yours. Any questions, comments, you can email us at randomjchannel@gmail.com. You can find us on Facebook at RandomJChannel, or you can comment below the video. Thank you for watching. Have a good one.